Hi guys, today I am going to say about the symmetric key. In that symmetric key there are so many types, and in that symmetric key there is a preference for RC4. So RC4 is also one of the symmetric key. RC4 means reversed cipher. So RC4 is the reversed cipher. Next, here I am going to say about the procedure for solving the RC4 problem. So it consists of three steps. First step is key scheduling, second step is key array generation, and third step is encryption or decryption. So let us see how we are going to do the key scheduling, guys. So key scheduling means, first of all, initially you need to take that j is equals to 0. Next, for I is equals to 0 to 255, the length of the bits are up to 255. Next, again j is equals to j plus s of I, that means index of the I value, plus t of I. So next is mod 256. Next, swap s of I comma j s of j mod 256. So this is the algorithm how to proceed for key scheduling. Let us see for key array. First of all, see all the algorithms how to solve. That means generally see the algorithms. After that, I will say how to apply this algorithm in the problem. So here in a key array, I comma j are in 0 at initial. While if it is true, then I is equal to I plus 1 mod 256. J is equal to j plus s of I mod 256. Next, swap s of I comma s of j. Then t is equals to I plus j mod 256. Then k is equals to s of t. So let us see that, guys, through an example. So this is an example, guys, which I took here. S array. It consists of S array and T array should consist of 8 bits. After that, plain text. It should consist of 4 bits. And key also should consist of 4 bits. In T array, the element should be repeated. How many number of that means it just should consist of 8 bits, guys. In that 8 bits, the total number of elements, how many you are taking, they should be repeated. If you take just only 1 2, then you need to repeat those 1 2 up till 4 times. If you take 3 values, that means 3 elements, you need to repeat them. So I just took here 3 numbers, that is 1 2 3 6, and I just repeated them. I got the 8 bits. Now let us see that here what we got. S array we got, T array we have, plain text and key we have. Now first step is key scheduling. What we need to do, guys, we need to assume that j is equals to 0. So here what I have done, that is j is equals to 0. Next, for I is equals to, they gave there 255, 0 to 255, because there what we have until 255 elements we have, but here we just have only 8. It means S array only consists of 8 bits. So here S array only consists of 8 bits, guys. So what is the length of that from 0 to, so here 0 to 5 6 7 to 8, that means 0 to 7. Next, j is equals to, what's the next step, guys? Here j plus s of I. S of I means index of I value, plus t of j. So here what I need to do, j is equals to, this is the j value. What is the j value at initial? J is equals to 0. So 0. Then s of I. What is the value of I, guys? Here initially I am going to take it as a 0. So that means S of 0 is 0 here. At initial S of 0 is 0. Next, what I have, plus T of I. That means T of I also, what at the initial it is 0. If it is 0, what I need to take, guys? Here 0 1 2 3 4 5 6 7. At index 0, what is the value of T of 0 is 1. 1, and just name it here. Then up to mod 8, that means here you just have 8 bits. So 0 plus 1 mod 8, that means 1 mod 8, 1 mod 8 is 1. Now what I need to do, guys, just swap s of I comma s of j. What is the s of I value? Initially what I took I value as 0 and j value as 0. Then j value as 0. Now what I need to do? Actually I need to swap s of j comma s of, that means sorry, s of 0 comma s of 0. But here I just wrote 1. Why, you know guys? Here at initial I just took j value as 0, but later j value is updated to 1. Later j value is updated to 1. So here in place of 0 we need to take the updated j value. So then I just took the s of 1 in place of s of 0. Now what I need to do? The next step is, so here s of 0 and then s of 1. That means these two places should be swapped. So what's the output I will get, guys? 1, 0, 2, 3, 4, 5, 6, 7. This is our updated S array, guys. Now we need to use this updated S array for next step. So again repeat the same step. J is equals to, again for here initially I just took that j is equal to 0, but now it is updated here. Just took the value. I am just implementing the formula s of I plus t of I mod 8. Now it is j value is here 1. 1 plus s of what's the value of I, guys? I value is now it is increased, that means 1. T of I value, that means in place of I what we have now, it is 1. So T of 1 is 2. Place it here, guys. Now mod 8. Then 3 mod 8 and then 3 mod 8 is 3. Now swap s of 1 comma s of 3. That means in place of j what we need to write, guys? Updated j value, that is 3. Now after that what I need to swap, that means swap, guys, that is s of 1. It is 1 value and s of 3. This is a 3. Then and play what I need to just shifting here, guys, 1 and 3. So here 3 and 0 and all remaining places are same. So like this you need to complete up to you that means you should reach up to s of 7, guys. That is the last element which is present in the array. So now let us move to the second step, that is a key array. So until now what we have done, we just completed the function of the swapping of s of I comma s of j totally. Now let us move to the second step, and for second step now I am going to showing the output, that means as input from the first step and output for the first step. Same thing I am showing here. Let us see that, guys. So this is the output of the first step, that means after swapping all s of i's and s of j's, at last I am going to get that 2376401 as a output, and the same output is the input for the second step. Let us see the second step in the next video, guys. Until then, bye bye.